I'm the author of Machine Learning with TensorFlow 2nd edition. My name's Chris Mattmann. I'm the Deputy Chief Technology Officer at NASA's Jet Propulsion Laboratory. I lead the innovation team there. Everybody that works for me does machine learning. It's kind of intimidating at some level, but additionally, it's something that is really inspiring too. People are using machine learning from everything at NASA JPL to mine and look at data now related to things like COVID, mining publications, trying to figure out treatments and diseases and things like that, all the way to looking at our clean rooms where we build the flight hardware that's on its way to Mars, like our next generation Mars Rover, which is called Perseverance. We're using machine learning to basically capture data in the clean room there, particulate data, to make sure that we don't contaminate the hardware that we're going to put basically on a rocket and fly to places like Mars and other places in the universe. We capture that data, we upload it to the cloud, and then we try and make predictions about whether or not we've contaminated the hardware. And we use things like TensorFlow, like we use in my book, and I'll talk about. TensorFlow is a modern machine learning toolkit originally started by Google. Maybe go through a couple of more examples real quick of some of the things that we're doing at JPL that's pretty cool. Another thing that we're doing, it's also Mars Rover related. Today, all of our space and flight hardware uses a very old processor, like an iPhone 1 processor called the RAD 750. And the reason that they do that is it needs to be what we call radiation hardened hardware that goes up, because when it gets up into space, there's cosmic radiation and it can do all sorts of crazy stuff, the least of which is simple things like flipping the bits, the ones and the zeros opposite, which can screw things up totally. So most of the hardware that we fly, nearly all of the hardware that we fly, is what we call radiation hardened, which means we've tested it. We've made sure that it can withstand cosmic radiation. Because of that, it's sort of made us a little bit of behind the curve in a way for getting, I would say, the type of hardware you expect on your laptop or terrestrially and things like that. GPUs, big computing to do deep learning, machine learning, and other things. But tomorrow, we'll have that. We'll have things like a chip called the High Performance Spaceflight Computer, which will be a GPU-like radiation hardened chip. Or we'll have things like Qualcomm Snapdragon, which is going to run on our Mars helicopter, which is pretty awesome as a technology demonstration. In these environments where tomorrow we'll have actual computing power to do machine learning, like what could we do? So some of the things my team is doing at JPL is envisioning sort of what are the killer apps that they could use in those environments. And so a couple of them are, we use about 200 images a day to get back from Mars. It's because it's about an 8-minute sort of round trip light time from Earth to Mars to send a message and get a response back. So we use about 200 images a day to plan what to do the next day on the surface of Mars with our existing rover there, Mars Curiosity, or MSL, Mars Science Lab. But tomorrow, what we'd like to do is run deep learning on the rover itself with one of those newfangled CPUs like I talked about, use one of those high-performance spaceflight computing or Qualcomm Snapdragon type of chips, and run a machine learning model on board. And tomorrow, get back 1 million captions, right? Because text is cheaper to send back than images and things like that. And if we could run machine learning and deep learning on the rover, caption what it sees, we could get back millions of captions rather than hundreds of images, and then have something really cool and a lot more information to do planning for the next day of rover operations. Those are just some of the cool things that we're doing with TensorFlow. Sort of besides that, one of the things I wanted to talk about, here is my book. And so how did I get started in machine learning, and, what types of problems are machine learning technology sort of best suited for? So, like I said, my team, we're the innovation team at JPL. And basically what we do is we work on very hard problems, like I was just talking about, like figuring out how to use machine learning for the next generation of Mars rovers, or decontaminating our clean rooms where we're sending flight hardware and things like that. In those environments, how are we using machine learning? Well, we're doing things like making predictions. We're classifying things. We're classifying images. We're, looking at an image and generating the text for it. So those are some of the awesome things that you could actually use TensorFlow and machine learning toolkits to kind of take care of. So how did I get started with TensorFlow, and why do you care about it here in the book? My team has been using TensorFlow and other machine learning toolkits for a long time, for the past few years. And I'm a classically trained sort of statistical person. I didn't know a ton about machine learning and deep learning 2 years ago. And as a former Manning author, I wrote about 10 years ago the book Tika in Action. Basically, as a former Manning author, I get Manning books. And so I either browse them or peruse them or grab them. And I saw the first edition of Machine Learning with TensorFlow that was written by Nishant Shukla, who's a recent graduate in 2017 of UCLA's PhD program in computer vision. And I was reading the book and it was really amazing. I mean, I like to learn practically and using applied knowledge. And basically there was tons of examples in the book, tons of just here's how you take the code and use it. Very practical, very easy to pick up. And so I started kind of working my way through it. There was a chapter on regression. There was a chapter on classification. There are chapters, in the book about how to do convolutional neural networks and machine learning and things like that. As I got started kind of going through the book, one of the things that kind of hit me hard, Nishant had this habit of, at the end of a chapter, putting in the bullets kind of at the end. Oh, by the way, yeah, I just taught you about regression. Why don't you download this data from New York's 311 call center, which has a bunch of their call data, and why don't you make predictions about, their monthly call cycles and how many calls they're going to get next month and things like that. Okay, so that seems kind of easy until you get started. And what happens when you get started is you realize there's a lot of data preparation, a lot of cleanup, a lot of downloading, and just getting the data what we call analysis ready or machine learning ready. And that really wasn't covered. And, I teach at USC. I'm a computer science professor there. I teach graduate courses in big data and search engines. And I'm sitting there 5 weeks later and, my wife's asking me, hey, why are you staying up so late at night? And I'm like, I see the future. It's machine learning and I'm doing it. And so I spent about 9-10 months going through the book and really, really taking my time with all of the, quote, suggested examples at the end of it. And what happened was about, a year later, I had a whole new book, basically. I had a whole new book. I had tons of Jupyter notebooks. I had a GitHub repository. I had these very in-depth notebooks where I took a bunch of notes and walked through all of the data preparation steps that you need for machine learning, with TensorFlow. And basically, that's how the second book was born. That's how the second edition was born. I'm adding about 9 to 10 new chapters. Each one of those new chapters is basically, where a suggestion was made in the first edition of the book. And then I actually took the time to do that suggestion and walk you through the machine learning, the data preparation, the cleaning, and everything that was necessary to do that. So the book kind of starts out with traditional machine learning. It doesn't jump right into deep learning, convolutional neural networks, and things like that. It goes and teaches you models like regression, which is basically how to make predictions with continuous numbers and data, not labels or things like that, but how to take a bunch of continuous numbers and then predict the next set of continuous numbers. That's basically what regression is. It goes through classification, which is getting, a set of data that has labels associated with it, and then trying to predict labels of unseen data based on what you've seen before. That's classification. After that, it takes you through some other unsupervised techniques like clustering, which is a pretty cool technique, which basically looks at data and then tries to group it together just like anyone would. I got 3 kids at home. I'm constantly cleaning up after them. I'm constantly, I got 2 that are under 5 and they love to just go from room to room and make mess, especially during this time. And what do you do when you do that? You take, items and you sort them together, based on what seems to be the relationships between them. That's unsupervised clustering. We take you through that in the book. The same approach and process works for data as well. After that, in the book, we go through hidden Markov models or probabilistic models. Basically, these are making predictions, trying to predict the internal state when you can't directly observe it. It's kind of like trying to predict whether you should go out walking when really you want to know what's the weather going to be like. And, we all know how hard that is to predict. So that's kind of a classic example of what we call hidden Markov modeling. And guess what? TensorFlow, this great toolkit from Google, this great framework to do machine learning, it doesn't only do deep learning and machine learning. Although you may hear about deep learning and machine learning today as sort of the only machine learning, we'll talk about it in a sec, but There's lots of other machine learning, and it's actually a little bit better because these models like classification, regression, hidden Markov models, things like that, probabilistic models, they're all explainable. You can explain to someone why the model made a decision that it did. Whereas it's a lot harder to do that with deep learning and neural networks, and no one really tells you that. So basically, that's kind of the first 2/3 of the book. Is it walks you through, basic, getting started with TensorFlow, understanding basically what machine learning is, walking you through explainable models, and each one of those intermediate, models that it introduces, I add a new chapter where I show you, okay, we've taught the theory, and now we're going to go into an actual example of it. And it's not just sort of an afterthought in terms of a bullet where we kind of mention, hey, try this. We walk you through 20 pages or 30 pages of how to do it with a Jupyter notebook and things like that.